All right, guys, and again, I'm ready whenever you are, so go ahead and feel free to start typing those questions into the chat box. You can ask a specific problem from a textbook. You can ask something from a worksheet, from Delta Math, whatever it is. Sure, you just want like a generic idea of it, or is there a specific problem, or you want me to just write some random problems? Sure, yeah, let me just, I'm going to open up my textbook so that I can make sure that my problems are actually decent problems. I will say, because you want random questions, there's 3 different types of problems that are going to show up on your test tomorrow. So it is really important that you understand the difference between those types of problems so that you don't accidentally get them confused. And so the first type of problem that you can encounter is just straight up a single inequality. And I would have to say that those are probably the simplest of the ones from this chapter. They're very similar to what we're doing in chapter 2, which is, we just take a single equation and we solve that equation and we get a single answer. So this could be something like 2x plus 3 is less than 7, or it could get really complicated. 7 minus 3 times x plus 2 is less than 4 times 3x minus 5, right? Like, it could get pretty complicated. But again, it's just a single inequality. There's only one symbol in the problem. This has a less than symbol. I used a less than symbol in this one as well, but you get the idea. There's only one symbol. There's not multiple symbols. And if there are multiple symbols, then we get into the one that you had asked about, the compound inequalities, which we will definitely solve some of those. But a compound inequality is one where there's multiple symbols in a single question. And there's 2 different types of compound inequalities. The first type would be an AND problem, and an AND problem usually has something where in a single line altogether, there are 2 inequalities in that line. So here I have a less than or equal to, and then over here I have another less than or equal to. And that says that this is an AND problem. When you're all done with an AND problem, you should leave it like this. Okay, so this could be a final answer for an AND problem. And then when you're graphing an AND problem, usually what happens is, oops, that's supposed to be a positive 7. Usually what happens is you'll have 2 circles with shading connecting the 2 circles together. So in this scenario, we'll have a closed circle on the -1 and a closed circle on the 7, and then we shade connecting those 2 dots together. So that's what normally happens on an AND problem, is that it's looking for everything between the 2 numbers. I want all the numbers between -1 and 7, and so we just shade in the middle. You definitely don't want to shade past the dots on an AND problem, so you kind of use the dots as a stopping point. And then the other type of compound inequality would be an OR problem. On an OR problem, it would be 2 completely separate problems. Like this, and then it would type in the word or, and then it could be like, let's make it that. So then it could be like this. Okay, so that could be an or problem. So on an or problem, it would definitely have the word or typed into the question. And when you're writing your final answer for an or problem, it's very important that you type, or not that you type, but that you write the word or as part of your answer. So on an or problem, we definitely want to see that word or on the answer line. And so this is what it would look like when you're writing a final answer for an or problem. And then when you're graphing an OR problem, usually what happens, it's actually the complete opposite of an AND problem. So on an AND problem, you have 2 circles, and then you shade connecting the circles together. But on an OR problem, you're going to have 2 circles, and you're going to shade away from each other. And so that there's like this big gap in the middle, in between the 2 numbers, where there's no shading. So notice how these are complete opposites of each other. ANDs and ORs are opposites. So this is the second type of problem, compound inequalities. The first type was just straight up like single inequality, you solve it, you get an answer, you graph. Your answer will be a single number. You're not going to do like ands or ors or anything like that. For instance, like this first one right here, I would subtract the 3 and I would divide by 2. And I would say this is my final answer. We just leave it like that. Okay, so single, very normal, don't overthink it. Compound, it's a little bit more complicated. Make sure to pay attention to if it's and or. If it's or, you must write the word or in the answer. And then I've got our two graphs. And then the last type of problem is an absolute value. And an absolute value problem, it's going to have these bars in it like this, right? And there's going to be stuff inside, and it can have less thans or greater thans, or even equal tos, right? So if it has a less than symbol like this, first of all, you're going to get two answers because you're going to split the problem in half. For the second answer, you're going to flip your inequality around and you're going to change the sign of the outside number. So for your second answer, you're going to flip and change. And then if your original inequality is a less than, then you're going to write the word and in the middle. If you have absolute value bars and it's a greater than symbol, you're going to do the same thing. You're going to do once exactly how it originally looked. For your second one, you're going to flip it around and change the sign of the outside number. Okay, flip this around, change the sign of the outside number. If it's a greater sign, then you're going to write the word or in the middle. And the graphing is the same. So for if it's a less than and you wrote and, right, you would expect to have two circles with shading together. If it's a greater and you write or, you would expect to have two circles with shading apart. On absolute values, we can also have a equal sign, like this. You're still going to do the thing where you get two answers. So anytime you see an absolute value in a problem, you're definitely going to get two answers. Absolute value bars means that there will be two answers. On an equal sign problem, you don't have to worry about flipping the equal sign around because it will look the same both ways, but you do still need to take the outside number and you need to make it negative to get your second answer. And then if we ask you to graph an equal sign problem, we're looking for just two closed circles with no shading. So to graph an equal sign, just graph closed circles. All right, that's a very quick, very basic rundown of the generic, normal types of problems that can show up on tomorrow's test. So really quick, one more time. Maybe. Let's see. There we go. You can have a regular, normal, single inequality that gives you a single answer that would give you one circle and shading in one direction. You can have a compound inequality, and there are two types of that. There's an and inequality, which usually does not say the word and in the problem. It usually looks like this. And if it's an and problem, normally it's shading together. The other option is you could have an or problem. An or problem will definitely say the word or in the actual problem, and that one has shading apart. Next, we have absolute values. That's the one with the bars. Absolute value problems always have two answers, no matter what. Always. To get the second answer, you flip your inequality around and you make the outside number negative. If the original inequality is a less than, you write and. If it's a greater, you write or, and you graph like we talked about on the previous slide. There's also an option of an equal sign for absolute values, and if we ask you to graph that, it's just closed circles with no shading. I I have not gone over any special cases. Special cases would be things like no solution or all real numbers. We can definitely talk about those later if you want to. Right now, I know that you wrote down a word problem, so I want to help you with your word problem. So, because I didn't do that yet. So that's another type of problem that can be on your test tomorrow. There will for sure be a minimum of one word problem on your test tomorrow. So it is important that we can do these. Just a reminder on word problems, there will be 3 answer lines. On the first answer line, we want you to tell us what letter you're going to use and what it represents. On the second answer line, you're going to write down what inequality you plan on using to solve this problem. And on the final answer line, we want a sentence explaining the answer. All right, so this problem says a particular toddler has an average nap of about 2 hours and sleeps for 13 hours a night. Nap time and nighttime sleep can each vary by about 15 minutes. What are the possible lengths for the child's total nap and nighttime sleep? All right. So I'm not sure that I've seen this problem, so I'm going to have to figure it out on the fly, which is fine. About 15 minutes. So that means that the nighttime, the nap time of 2 hours, practice sheet 3-7. Ooh, I don't know that I assigned that to my students, but maybe I can find it somewhere. That means that average nap of 2 hours. You know what? Does it want you to write? It wants you to write an absolute value. This is a different word problem than what I was thinking of. Okay. It wants you to write an absolute value. I got it. Thank you for telling me which worksheet it was on. Okay, actually, let's go over here. Okay. On average, the nap time, let's call this nap time, can be 2 hours, which we'll call, well, I guess we'll just call it, no, we'll call it 120 minutes, 60 times 2. Just because the other one is minutes, I don't want to get like confused with units. So we'll call that 120 minutes. And it can vary by about 15 minutes, so that means it can get bigger. I'm sorry, not right there. It can get bigger by 15 minutes, which would put us at 135, or it could get smaller by 15 minutes, which would put us at 105. What are the possible lengths of nap and nighttime sleep? If we were doing just the nap time sleep, what you would do, and this is inclusive, so it could be 105, it could be 135, or it could be anywhere in between. So what you do on these problems is you do x minus, and then you take the middle number and you put it after the subtraction sign. And then if we look at this graph, this looks like an AND problem. And I talked on the previous slide that when it's an AND problem for absolute values, you put a less than symbol. So I'm going to put a less than symbol, and I'm going to say or equal to because I drew some closed circles. And then on the outside, you take the number that you added or subtracted, and you put that out here. So for nap time, we would say that we have a 120 nap time on average, but it can vary by up to 15 minutes. And so then we say less than or equal to, so that it's everything in between. So that should get us from 105 to 135. If we're going to do the nighttime sleeping separate, I need a calculator. The nighttime sleeping said 13 hours, I think. Yeah. So 13 hours times 60 minutes each. So that's 780. So for the nighttime, we could do x minus 780. still less than or equal to, and we still have that 15-minute leeway. So 15 minutes more would be, no, 795, and 15 minutes less would be 765, but regardless, it's 15 minutes out here. So I think that's what they want you to do. Honestly, I think I went over one of those problems with my students. I don't know that this type of word problem will be on your test, but for sure, if you need this for your homework, I would say it's this. If you want to, you can combine those both together. Combine these together. And so instead of doing minus 120 and minus 780, we would combine those together. 120 plus 780 is 900. And since we have a leeway of 15 minutes on each, that gives us a leeway of 30 minutes total. So if it's just looking for a single answer, I would say that this is the answer. That was super confusing, I think. I'm sorry if that was super confusing. And again, I don't know that there will be one that tricky on your test tomorrow. I think it'll be a little bit more straightforward with the word problems. I hope that helped. And I do see that we have another problem typed up, so let's take a look at that one. All right. This one's definitely more straightforward than the word problem. The first thing I want to point out is this is just a single inequality. There is one greater than symbol right here. Okay, and so I'm just going to get a single answer. There's no absolute value bars, so I don't need to split it in two. And there's no second inequality, so it's not a compound inequality. So just straight up going to solve for x and then graph it. The first thing you would do on a problem like this, you would take this minus 3 and distribute it into the parentheses. So that's going to make a negative 3x and a negative 15. Next, on the left-hand side of the problem, I have some letter x's that are like right next to each other. So I'm going to combine those together exactly how they look. So I have a positive 2 and I have a negative 3. So I'm going to go 2 minus 3. 2 minus 3 is negative 1. Next, I see I have a letter x on the left side and I have a letter x on the right side, and I'd like to get those together. So I'm going to take this negative x and I'm going to add it, and I'm going to add it. Now this problem is a special case, which we haven't talked about yet, but all of the x's are going to cancel. A negative x plus x will cancel out completely, leaving no more letter x's. And the same thing happens on the other side. A negative x plus ax will cancel out completely, leaving no more x's. And so now I have this inequality. I'm no longer solving for x because I don't even have an x. I now have two options for my answer. I have the option of no solution, and I have the option of all real numbers. So I got to pick which one is appropriate. And it all depends on if this statement is true or false. So this statement says that negative 15 is greater than 4. So I need to think if that's true or false. If it's false, we'll pick no solution. And if it's true, we'll pick all real numbers. And this is false. Negatives are not bigger than positives. That's not true. It's false. And so since it's false, we would choose an answer of no solution. And when the answer is no solution, when you go to graph, don't. The graph is supposed to represent all of the numbers that are answers to the problem, but we said this problem has no answers. It's no solution. And so if you write down an answer of no solution on an answer line, then you should leave the number line empty. You don't put any circles, you don't put any shading. And you definitely write no solution on the answer line. Don't write this. This should be shown in your work, but on the answer line, you're going to write no solution. And then you're going to leave your graph empty. You don't even have to put any numbers on it. Just leave the graph completely blank. Okay, yes, and then that's a great follow-up question. So there are other scenarios where we can get no solution. So let's call scenario number 1 is if you're solving a single inequality and you get a false statement, like 3 is less than 0. 3 is not less than 0. 3 is greater than 0. We would say no solution. We leave it blank. Another scenario is the one that you typed in there. An absolute value equals a negative number, any negative number in the whole entire world. That is false. Absolute values are always positive numbers. And so if we have an equation that says that an absolute value is equal to a negative number, then we say that you can't do that. That doesn't work. You don't even try to do the problem. Like if you have an absolute value of it doesn't even matter, and on the other side the number is negative, that's an automatic no solution, and you don't do any work. You just, if you want to show work, what I usually do is I will circle this negative number to explain why I decided that there was no solution. Another scenario with absolute values where it's no solution is if you have an absolute value that's smaller than a negative number. That also would be no solution, because now you're saying I have a positive number that's smaller than a negative number, and that's not possible. Okay, so those are the absolute values that can be no solution. And then you can also have a no solution on compound inequalities, specifically on an and inequality. So what normally happens on an and inequality is you have a small number and it's less than x, and that's less than a bigger number. And that's fine because I can put something here that will work. 8. 8 is bigger than 2, but smaller than 10. So it's nice and it's in order. Sometimes though, when we have an and problem, it doesn't look like this. Sometimes it says a bigger number is smaller than x is smaller than a smaller number. And in this scenario, where the bigger number is first and the smaller number is second, and these are less than symbols, that's not going to work. Because what happens is it says, I want numbers that are bigger than 7, and I also want those exact same numbers to be smaller than 2. Well, I can't do that. The numbers that are bigger than 7 are over here, and the numbers that are smaller than 2 are over here. That's not possible. And so sometimes on an and problem, you might get an answer of no solution. And if the answer is no solution, again, leave the number line blank. If you start trying to draw circles on here, that's a wrong answer. If it's a no solution, don't put anything at all on the number line. So just leave the number line like this. Okay. Another way this could have been written, if they have the smaller number first, but they use greater than symbols, that's also bad. So what we really want on an and problem is smallers with less thans, or bigger with greater thans. But it needs to be in the right order. Okay, I hope that helped. Those are all the no solution possibilities. If you want to, we can run through all of the all real number possibilities. That's the other special case scenario. I know someone's typing right now. Okay, let me run through the all real numbers possibilities, and then when I'm done running through those, in the meantime, if you have another question, like type it in, right? I will answer your questions when I can. But since we went through one special case, I wanted to go through the other special case. So you can get all real numbers with a single inequality. And so if you have a single inequality where there's no more variables and it says like 3 is less than 5, then you say, yeah, 3 is less than 5. That's true. And then on the answer line, you write all real numbers. And if you're going to tell me that the answer is all of the answers, it's all real numbers, then on the number line, you need to show me that everything in the whole world is an answer. And you can show me that by shading the whole number line. So if you wrote on the answer line that the answer is all real numbers, then on the graph, you just shade the whole thing, all edge to edge, all the way across. So that's scenario 1 for all real numbers, is you're solving a single inequality. All the variables have disappeared, but you get a true statement. 3 is smaller than 5. Scenario number 2 would be for an OR problem, and I do see that we have an OR problem up there that you want to see done, and I will for sure do that as soon as I'm done talking about this. Okay, so on an OR problem, normally when we go to graph it, it's 2 circles and then the shading goes away. Sometimes though, we might have an OR problem where when we go to graph it, it's very important that it said OR. When we go to graph it, the shading goes towards each other. This says I want numbers bigger than 2. Well, that's going to go this way. And I want numbers smaller than 10. Well, that's going to go this way. So if you get an OR problem that overlaps, if you get an OR problem that looks like maybe it should have been an AND problem instead, that's actually an all real numbers problem. Same with the AND problem. If you get an AND problem that looks like an OR, that's a no solution. So, like, if the graph is the opposite of what you think it should be, then that's a special case. So if you're doing an AND that looks like an OR, write no solution. If you're doing an OR that looks like an AND, write all real numbers. And don't just assume it's going to be what you think it's going to be. Like, really pay attention to which way you're supposed to be shading. Don't let the special cases like trip you up. Scenario number 3, you can actually get all real numbers on an absolute value problem. If you have an absolute value that's greater than a negative, that's actually an all real numbers answer. Because, again, absolute values are positives. So this is saying I have a positive number that's bigger than negative 3. Well, all the positive numbers are bigger than negative 3. This will always be true. This always works. So if you have absolute values and a greater than and a negative, that's actually all real numbers. You're going to end up shading the whole thing. Now, if you can't memorize that, you could actually do the problem. This would be x plus 2 is greater than negative 3, or x plus 2 is less than positive 3, and you'll get x is greater than negative 5, or x is smaller than 1. And when you go to graph that, it's an OR problem, but when you go to graph it, it's going to end up like doing that overlap thing, like I said earlier. So these are the 3 scenarios for a special case of all real numbers. And again, if you wrote down all real numbers on an answer line, make sure that you're also shading the entire number line. So the graph should match what you said was the final answer. All right, let's take a look at that OR problem that you typed in there. So it says 4x plus 1 greater than 2x minus 1, and then it says the word OR. It's really important. And then it says 5x is less than negative 10. You mean for like the special cases, hun? Um, yeah, so on the absolute values, sorry, I promise we'll come back to that. I just want to make sure I understand what she's asking. An absolute value means this is going to be a positive number. So if we ever say an absolute value equals a negative number, that's bad. That's no solution. Or if you say an absolute value is smaller than a negative, that would be saying a positive is smaller than a negative. That's bad. That's no solution. But if you have an absolute value that's bigger than a negative, that's okay, because positives are always bigger than negatives. So that's the one that would be all real numbers. If you have an absolute value and the number on the other side is a positive number, that's where you have to split it up, and you do it once exactly how it looked, and the second time you flip your inequality and make it negative. So if the absolute value has a positive over here, then you got to do some work, and that's where you split it up and you'll get two answers. But if this outside number is negative, you can go straight to either no solution or all real numbers. I think that was what you were asking. And if not, maybe like type in a problem for me and I'll do that. All right, back to this OR problem. On this OR problem, first of all, on OR problems, it's really two separate problems. And so you're going to do one problem completely, and then when you're all done, you'll go back and you'll do the other problem. Oh, good. Okay. So I'm going to do the left one first because it's on the left. And I'm going to start by moving the 2x over. So I'm going to subtract this 2x on both sides. Over here, they cancel. All right, and then I'm going to minus this 1 over. Sorry, hold on a second. I need to message someone. Okay, I think we're good. All right, so I minus the 1, and that cancels. Gone. -1 and -1 makes -2. I recognize this problem. I think it's from a homework or a quiz we just did in my class. I'm going to divide by 2, and we get x is greater than -1. I do want to point out, we haven't talked about this yet tonight. When you're multiplying or dividing, you have to pay attention to if your number is negative. In this particular example, I am dividing by a +2. And so I don't have to really worry about anything. Even though my answer is a -1, I'm dividing by a +2. If you ever divide by a negative, if the number that you put down here is negative, then on your next step, you need to flip your inequality and make it point in the other direction. So we haven't really talked about that yet. We haven't seen a problem like that yet, but that's for sure something that you're going to need to remember for tomorrow. All right, and then on this one, I'm just going to do one step. And again, I'm dividing by a +5, so I don't have to worry about flipping my inequality or anything. So I'm going to go like this, and that's -2. Okay, if I draw a number line out, when you're doing negatives, first of all, make sure you're going to the left of the 0. Several of my students keep putting negatives to the right of the 0. I'm not sure why. Don't do that. Negatives always go to the left, and they go kind of in reverse order. So -1 will be closer to the 0, and -2 will be further away from the 0. So make sure that you put your numbers in the right order. If you accidentally mix up the order, then your graphing is going to be wrong. Also, this is what you would write on the answer line, right? That whole sentence. If it's an OR problem, you have to write the word OR on the answer line. So you can't not write a word. All right, and then for the OR problem, we're hoping, if this is normal, that we're going to get 2 circles and shading going apart. So looking at the -1, first of all, it's going to be an open circle on the -1. And then this symbol is a greater than symbol, so I want to go to the right. So I'm going to start at my -1. I'm going to shade all the way to the end. Looking over here at my -2, that is also an open circle. And the -2 symbol is a less than, so I'm going to start at the -2 and I'm going to shade to the left. And that's a normal OR graph. And so this is it. I'm done. That's the answer. And then Jonathan, I think you're asking shaded in as in like shaded towards each other. And so the answer is yes. So normally when we're doing OR problems, we get something like this. And then like you graph them out in the correct order. And when you go to graph it, it goes away from each other like this. And so that's a normal OR problem. But sometimes we'll get an OR problem where we put the numbers on the number line in the correct order. So again, very important that the numbers are in the right order. So if you accidentally mix up the order of the numbers numerically, then you could get the wrong graph, right? So it's not about like the 10 is first and the 2 is second. It's like 2 should go before 10, 1 should go before 5, right? Okay, so if this is an OR problem, I'm going to go to my 1, and I'm going to put an open circle, and this is shading towards the 5, and that's okay. You actually want to keep shading to the end if it's an OR problem. If it's an OR problem, don't stop till you hit the end of the number line. Same thing with this one. I'm going to circle here, and I'm going to shade, and I don't stop till I get to the end of the number line. And this is that special case where we said that the final answer that you would write on the answer line is all real numbers. And I think that was the question you were asking, and if it's not, can you please tell me? And I can help out a little bit more if that's not what you were asking. And I don't see any other new problems. Oh, perfect, great. I don't see any more new problems. So does anybody else have something that they want me to go over? You can do like the other people have been doing. You can type in a specific problem, or I brought my textbook. So if you are working on a textbook assignment and you want to just tell me like the page and the question number, I can do that. I do have some worksheets and quizzes from some of the teachers, but not necessarily all of them. But it doesn't hurt to ask. Ooh, we already went over those. I'll back it up for a second while other people are typing. So we said earlier that there are 3 different types of problems. There's a single inequality, there's a compound inequality, and there's absolute values. And each type can have a no solution or an all real numbers answer. So on a single inequality, for a no solution, there would be no more letters left in the problem, and you would get a false statement like 3 is smaller than 0. That's false. Then you would write no solution. On an absolute value problem, if it's equal to a negative, it's a no solution, or if it's less than a negative, it's a no solution. And then on compound inequalities, you can only get no solutions on an and it has to be it has to be an and that when you try to graph it, it looks like an or. That would be a no solution. So those are the no solutions. And then for the all real numbers, for a single inequality, you would get a true statement. So 3 is smaller than 5, that's true. Then you would write all real numbers. For a compound inequality, if you get an or that graphs like an and, where the shading is going together, that's an all real numbers. And on absolute values, if it says an absolute value is bigger than a negative, that's an all real numbers. And this is being recorded, so I know I went through that really quickly because you missed it, but after we're done, this will be posted online and you can go back and you can watch. And I explained it a little bit more in depth when I explained it the first time. Um, okay, so just if this is the wrong problem, like, let me know. But my chapter 3 quiz number 12 says -2 is less than x plus 1 over 3 is less than or equal to 13. So if that's not the right problem, please tell me. Okay, awesome. Um, so okay, and I'm going to answer that other question in a little bit. So this problem is an and problem, and I know that because I see two inequalities in the same problem, and I don't see any words. So if there's two inequalities, but there's no words, it's automatically an and. And our goal on this problem is to get the middle to be all by itself. So, or to get the letter in the middle to be all by itself. So like, I don't want that x, I don't want anything with the x in the middle. Now in this problem, we have a ginormous fraction that takes up the entire middle of the problem. And so we're actually going to get rid of that fraction first. And I don't normally say that. Normally I'll tell you to get rid of the fractions last, but because it's so big, we actually have to get rid of it first. And the way that we get rid of a fraction is we multiply by the denominator. Now on these and problems, whatever you do, you have to do in 3 places. You'll do it once in the middle, once on the left, and once on the right. So it's really important that you're multiplying in 3 places by the number 3. And in the middle, we're actually not going to multiply by 3 because the 3's are going to cancel. And so I'm just left with the numerator, which was the x plus 1. On the left side, 3 times -2 is -6, and on the right side, 13 times 3 is 39. The next thing that I'm going to do to get the x that's in the middle all by itself is I need to take that plus 1 and I need to move it by subtracting. And again, you'll need to subtract in 3 places. You can't pick and choose and be like, oh, I'm just going to subtract in the middle and on the right side. It's everywhere or nowhere. So make sure you're subtracting left, right, and middle. And so then we get -6 minus 1 is -7. These have canceled. 39 minus 1 is 38. And my x in the middle is now all by itself, and so we're good. We're ready. Yeah, I got Harvey's chapter 3 review number 2. It has 17 problems on it. I hope that's the right one. Okay, let's graph this because we do have to graph. And we don't want to get tricked and have this be a no solution problem, so we're going to be a little bit careful about our graphing. And so what I always tell my students is the first one, they should flip around to get the letter on the correct side. So we would graph this like at the -7 and going this way. And then the 38 is here and going that way. And you know what? That's exactly what we expect on an and problem. And so I'm going to go ahead and write my final answer down here, which is an open circle on the -7, a closed circle on the 38, and shading connecting together. And please notice that my shading does not go past the dots. On a regular normal and problem, my shading will not pass the dots, and it's just kind of kept in the middle. Okay, so that was number 12 from the quiz. This is what you would have written on the answer line, and then that's what your graph should look like. All right, and then we had a question about absolute values and how do you know if it's an and or an or. So what I do, I talk funny, and that tells me if it's an and or an or. Now this is only true for absolute values. This is not true if there's no absolute value symbols. So it's got to have absolute value symbols. So what I do is I say in my head, because you're not allowed to talk out loud during a test, I say, this is a greater symbol. Greater symbol. So we are going to write the word or for that problem. So if the original inequality, before you split it, before you do anything, is a greater symbol, when you split it up, you're going to write the word or. But if it's not a greater symbol, if instead it's a less than symbol, a less than symbol is the word and. I know that looks weird, I'm sorry. So if you just kind of say it weird in your head while you're writing down the problem, that'll help you figure out what word to use. So again, when I'm doing these problems in my head, I'm secretly saying x minus 3 less than 3 and x minus 3 greater than negative 3. And so I just kind of say it funny in my head, and that reminds me less than is and, greater is or. And it's all dependent on what the original inequality was. Because eventually you are going to switch it around and make it go the other way when you make that outside number a negative number. So just pay attention to the first one, and that's where you get your word from. And on an equal sign problem, you don't have to write a word. If you do want to write a word, it would have to be the word or. It definitely cannot be the word and. But on an equal sign problem, we usually just write down like it's 5, 10, or whatever it happens to be. All right, Matt, I do see that problem, and we're going to go ahead and do that one right now. So it's 2 absolute value, 2 plus 2x plus 6 greater than 30. So one thing I want to point out on this problem is that there's a bunch of stuff happening that's not inside the absolute value bars, and that's really important. And we actually have to get rid of that stuff before we can do anything with the absolute value bars. So what I usually do with this problem is I'll take a highlighter and I'll cover up the absolute value bars with a big highlighter X. And essentially what's happening is I'm changing the problem. Instead of saying 2 times the absolute value, blah, 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 plus 6 is greater than 30, I'm making it say 2x plus 6 is greater than 30. And my goal is to get that yellow X, which is actually my absolute value bars, to be completely by itself. So to get that yellow X to be alone, the first thing I'm going to do is I'm going to subtract this 6 from both sides. Okay. Now, my yellow X is still not by itself because there's a number 2 right in front of it. If there is something right in front of the absolute value bars, that means it's being multiplied with the absolute value bars, and so if I want to get rid of it, I would divide. And on this side, it just cancels out. And I now have my absolute value bars are completely by themselves. I don't have anything else going on outside of the absolute value bars. And so once that happens, here is where you can split this and make it 2 separate problems. My first problem would be 2 plus 2x greater than 12, or, and then my second problem would be 2 plus 2x less than negative 12. And then we would go from there. Make sure to write the word as part of your answer. So here's my final answer on my answer line. And since it was a positive number out here, we know for a fact that this one's going to be just like a regular or problem where we get a circle and shading and a circle and shading, and the shading goes apart and there's a nice big gap in the middle. And so that's how you do that one. All right, let's take a look at that next one. Maybe. There we go. Negative 2x greater than 6, or is there something that's supposed to be between the 5? Oh, 5, perfect. Okay, that's what I was just wondering. 5x plus 3 greater than or equal to 28. All right. So again, on these OR problems, it really is two separate problems. There's the first problem and the second problem. So on the first problem, and this is something I kind of talked about earlier, but I haven't actually shown you yet. The first thing you're going to do is you're going to divide by -2. And anytime that the number under the division sign is a negative, on your very next step, you're going to flip your inequality and make it go the opposite direction. And I actually like to write that first. So as soon as I'm like, oh, I'm going to divide by a negative, then I go, boom, switch it, before I write down anything else on the next line, so that I don't forget that this needs to flip because I divided by a negative. That's also true if you multiply by a negative. All right, so that's x, and then this is -3. Over here, I'm going to -3. We don't worry about flipping on any adding or subtracting. And I'm going to divide by a +5, so again, I don't have to worry about flipping my inequality. And so here is my answer for my answer line. Maybe if it's a regular OR problem, that's definitely the answer for the answer line. I guess I should probably graph it before I decide that. Okay, so on the -3, I have an open circle, and this is a less than, so I'm going to shade to the left. On the +5, I have a closed circle, and we've got a greater than, so I'm going to shade to the right. And so it is a normal OR problem, and so I can just stick with my normal OR answer. All right, guys, we got about 10 more minutes. Well, a little teeny tiny bit less than 10 minutes, but I think I've answered everything that was typed. So if you have any last minute burning questions that I can answer in the next 10 minutes, now would be the time to let me know. I think one thing we didn't talk about was if the letter is on the wrong side. So if you finish a problem and you have like 3 is less than x, definitely don't leave it like that. When you go to write it on the answer line, you want to flip-flop everything, including the inequality. So some things that I saw my students do, they left it like this. And then when they went to graph it, they thought that they were supposed to shade this way, which is incorrect. Because if you actually flip everything around, you'll see that I actually want it to be bigger than 3. And so this one down here is the right way to do it, and this one up here is the wrong way to do it. So make sure when you're writing it on your answer line that you have the letter first and the number second. Sorry, excuse me. I think going back to like what types of problems there were, it's probably about half just straight up regular single inequalities because we spent the most time on that. And then of the other half, half will be compound and half will be absolute values. So what is that actually, like a fourth and a fourth? Half of a half. We can do fractions. We're doing math class right now. So I think that's about the breakdown. So I don't think it's like too intensely compound and absolute value. I think that if I had to choose the one that happens the most, it's probably the normal straight up single inequality. I'm pretty sure there will be special cases on your test tomorrow, so be hyper aware of if it's no solution or all real numbers. That being said, it's not going to happen a ton. Maybe 2 or 3. Maybe I could even be exaggerating that. It might just be 1. But don't go like crazy and say like every other problem is no solution. That would not be a good idea. All right. I've been doing some compounds. We've been doing some ands and ors. Is there a specific one you're looking for, hun? Because I have done some. Compound is the ands and the ors. Can I, oh, okay, cool. I'm going to change the letter to an X because it's easier for me to write. All right, so this is just a straight up like single inequality. I know that because I only see one inequality symbol. It's just this one right here. And I don't see any absolute value bars. So this is a very normal problem. We don't want to overthink it. The first thing I'm going to do is I'm going to take the negative 6x and I'm going to move it to the other side to be with the 8x. 8 plus 6 is 14. Okay, and then I'm going to add this 3 away from the x. And I'm going to divide by the 14. So me personally, I like fractions. So I'm going to leave this a fraction. I am going to simplify it. So these can both be divided by 2. So I'll simplify this to 5 over 7. And then I literally just talked about this. This was like the one thing we hadn't talked about yet. I don't want to end a problem with the letter on the right-hand side. I really super want the letter to be first. So I am going to flip-flop the entire problem. So I put the letter on the, I switched the letter and the number, the answer, and then I flip-flop my inequality. And so this is what you would write on your answer line. And when it's just a single inequality, you have one circle. This is an open circle, and you just shade in one direction all the way to the end of the number line. In fact, on most problems, you're going to shade to the end of the number line. The only time you don't is on an and problem. You shade caught in between the circles. And then on a no solution, you just like don't shade at all. All right, and we got another absolute value problem. This one is very similar to the one that was asked earlier, where I'm going to take my yellow highlighter and I'm going to cover up my absolute value bars because there's a bunch of stuff happening outside of them, and so I need to get rid of that stuff first before I actually deal with the fact that this is an absolute value problem. So I'm going to pretend like this problem says 2x plus 8 equals 4, and I'm going to solve for the yellow x. And the first thing I'm going to do is I'm going to minus the 8. Okay, and my yellow x still is not by itself, so I need to do one more step. Remember that this 2 is right next to the absolute value bars, which implies multiplication. So I'm going to do division next. Those will cancel. And now my absolute value bars are all by themselves. Normally here, I would say, okay, let's split it. Let's find some answers. But I happened to notice that I now have an absolute value that we are saying is equal to a negative. We talked about this earlier today. Absolute values are positive numbers, and positives cannot equal negative numbers. And so I'm actually going to stop right here. And if I was taking this test, I would circle the -2 right now. And then on the answer line, I'm going to write no solution. And if there's a number line typed on the test, I'm not going to touch it. I leave it blank. I don't put any numbers, no circles, no shading. No solution means there are no answers, so I don't need to color any answers. All right, guys, that's the last problem I see. We have 2 more minutes, so if you have a very quick question, I can answer that quick question. I do want to say that the tomorrow morning's tutoring has been moved to Miss Carter's room. She is in room 303. And so if you normally attend morning tutoring, tomorrow's morning tutoring will be in room 303 with Miss Carter. Room 303. Morning tutoring. So if you need that last minute session before school starts to just give yourself a little extra confidence, you can go there and ask her for help. She will be there at 7 o'clock. 7 a.m. So as long as you're there sometime after 7 o'clock, she will be there. All right, do you guys have any other questions? All right, if you don't have any more questions, I'm going to go ahead and sign off. And thank you all for attending. And I hope this helped. And good luck on your test tomorrow. And you're welcome. Glad to do it, guys.